gone through and found that the derivative of e to the x is e to the x. Therefore, the integral of e to the x would be e to the x plus c. Okay, because remembering that derivatives and integrals are opposites of each other. So the reverse process. ln x. What's the derivative of ln x? Again, if you've still got your booklets out, you should be able to see it. 1 over x. So therefore, the integral of 1 over x would be ln x plus c. Yes? Yes, hello? Yeah. One yes? Yes. Yeah. Okay. Trig functions we haven't done yet. We're going to cover those later. Now, this is where it comes in. Remember, you're not just going to probably have e to the x. You're going to probably have something a little bit more complicated than that. So if you have e to the ax, so if you have e to the something x, then this should be it. Yeah. Then it would be e to the ax over a plus c. Yeah, so for example, if you had the integral of e to the 4x, then actually you should have dx here. It would be e to the 4x over 4. Yes. Yes. So if you recall, I don't want to confuse people. So if we had e to the 4x and we were differentiating it, it would be e to the 4x multiplied by 4. Yes, remember that? So in a similar vein, if we're integrating, now I've got a bit of paper. If we're integrating, it's going to be e to the 4x, but this time we're going to be dividing by, remembering that they're opposite operations to each other. Okay, so that it is linked with each other. So if you remember one, hopefully you will remember the other. If you have the integral of a over x, okay, so again, a can be any number, then the derivative, the integral would be a ln x. Okay, so if you had the integral of 5 over x, then it would be 5 ln x plus c. Essentially what we're saying is this, that if you have e to any kind of function, then it's going to be that same expression divided by the derivative of that function. Okay? And that works for this thing up above here as well. Because if I've got e to the 4x, then what's the derivative of 4x? It's 4, yes? So that's why it's e to the 4x over 4. If I've got something fancy pants like e to the 2x cubed minus 5, okay, so if I'm integrating that expression, it would be e to the 2x cubed minus 5 divided by the derivative of this. So what's the derivative of this expression? This is a 6x squared plus 6. Sure, so you've got your head on your hands. Do you happy with that? So you've got e to the any kind of expression. Yeah? So in this particular case, it's 2x cubed minus 5. Then the integral would be that same thing on the top, and the derivative of that expression goes on the bottom. Okay? So actually, you only need to remember this. You don't have to remember this bit. Where did I get 6x squared from? It's the derivative of this expression here, the 2x cubed minus 5. Yeah? the derivative of the one. And again, if you recall, it's the opposite of what we were doing when we're differentiating. When you're differentiating, it's that same thing multiplied by the derivative. Here, we've got, if you can spot that there's the derivative on top and the function is on the bottom. Okay, so if this on what's on the bottom and then its derivative is on the top, then it's going to be just ln fx. Okay, so if you recognize that that's what it is, then it's just going to be ln of that function. Right, let's go through some examples. So, integral e to the 5x dx. Trishna, what is this one going to be?
It would be e to the 5 plus e.
Lovely. How else might they write this in the textbook? This is where it comes in, sometimes we come unstuck because we look at the answers and think we've done it wrong. How else can you write this?
1 over 5.
Good. 1 for e to the 5x plus c. So that's exactly the same. Because this divided by 5 is the same as saying 1/5 of that. Yeah? So just so you're aware in case the answers in the textbook look different. Okay, example 2, Ali. Help me out with this one. Okay, so we're going to look at this here, because we've got e to a function, okay? It's not just a number and it's not just x. So we're going to follow this rule. So what's our answer? It's going to be that exact same thing. See how this is e to some kind of expression?
Yeah, so 2x plus 1.
Yeah, so it's e to the 2x plus 1, yeah? So it's going to be, right, so our answer is e to the 2x plus 1 over what? X. Because that is the derivative of 2x plus 1. Yeah, light bulbs going on? Yes. Sorry? Yes. So this is the integral of 3 over x. Okay, so there aren't any e's involved, so we're probably looking at the other side of the page for the example. So we've got 3 over x. 3 over x. So what will our integral be for this one, Sarah? Lovely job. Now, just thinking about it, that may help to consider 3 over x as 3 lots of 1 over x. Does that make things easier?
No.
Yeah.
No.
Yes? No? Well, let me explain why I think it might become easier, because this 3, do you appreciate that 3 multiplied by 1 over x is the same as 3 over x?
Yeah.
Are you happy with that? I've just split it. So secretly that's 3 over 1 and that's 1 over x.
Yeah.
Okay, so I've just split it. Well, what's the derivative, what's the integral of 1 over x? And so that's why it's 3 ln x. Possibly easier to think about like that.
It's easier, but it's cool.
It's a different way.
I'm not going to remember to think of it. Like if it's written as 3 over x, I'm going to remember the way to do that. Yeah. Because like the first way we learned it was a over x.
Okay.
So I'm not going to go on my until we learn that like,
Sure.
it's the same thing.
I'm hearing you, sister. I'm hearing you, sister. All right. Right, this one here. What do we do when we have stuff that looks like this?
You break it up.
Nice. How do we break it up, Jennifer?
X squared over
I'm not quite sure.
so x squared over x plus 3x over x minus 2.
Trishna is winning a prize.
Really?
Well, no,
You can steal your prize.
All right, so notice with this, I haven't actually done anything yet, so I still have to keep my integral sign. So with the others, I actually could write my answer because I was actually integrating it. This one I haven't yet, so I've got to keep my integral sign and my dx. Now I'm going to try and simplify it if I can. So, Cameron, I've got x squared over x. What does that actually become? Nice. 3x over x. Olivia, what does that become? Nice. That's 3. And then you've got minus 2 over x. That's fine. We can keep it like that. Okay, so we're integrating. Skylar, can you integrate this for me, please? Remember, step by step. So x becomes what? So normal rules, what do we do when we integrate? We're adding 1 to the power, x2, and we divide by our, good, and then plus what? 3, what secret power do I have of x here at the moment? 0. So when we're adding 1 to it, it becomes x to the power 1, yes? If you want to secretly over 1, we can write that. Yep. No, because then what's negative 2 over x? What does that become? Negative 2 over x. It was similar to this example here. Nice. And we've got a subtract sign, so it's going to be negative 2 and then plus c, obviously. At some point, I would then rewrite it without this power of 1 and that 1.
Wait, that's it?
Yeah.
Can you do that?
Yeah.
So that's our normal integration. Okay, so our current power is 1. So the rules of integration is you add 1 to the power and divide by the new power. So this becomes x squared over 2. This is a constant term.
Wait, you add 1 to the denominator as well?
No, so you add 1 to the power and divide by that new number. Yeah. This currently has no x next to it, so we could consider that as being x to the power 0. Yes?
Yeah.
And so when we add 1 to that, obviously that's going to become 3x to the power 1 divided by 1. Okay. And then this was the 2 and an x. And then we wouldn't keep our powers of 1 and divide by 1. We would just write x squared over 2 plus 3x minus 2 and an x. Let's see.
What happens with the x?
So remember, this and this just tells us that we're integrating. So that's always part of the question. And that's why it was a bit naughty of me, I apologise. I should have had that in all of these questions. I should have had dx next to all of them.
Yeah, Ms. Harrison, that's 14.
That's okay. There's just a couple more examples. So again, this is the summary. So 1 over x is ln x, e to the x, e to the x. Okay, so that's our summary. Bless you. So find the indefinite integral 4 over x. Jennifer. 4 over the x. 4 over x becomes when we're integrating it. There's only one person called Jennifer in here.
4 ln x plus
Lesbians. E to the power t over 2. Now we haven't really talked about this over 2, but this is where we have to use our noggin. And remember that if you've got things divided by 2, we just talked about this. If you've got things divided by 2, it's the same as saying that this question could be written as 1/2 e to the t. So e to the t over 2 could be written as 1/2 e to the t. Okay? Now, what was the deal when we differentiated stuff with a number in front of it? Did the number in front of it change at all? No, it was just there, yes? And the same thing is going to happen if you're integrating. So 1/2 e to the t would integrate to be 1/2 e to the t plus c. Okay? Pardon? No, because my half is a coefficient, it's in front. It's not in front of the t. See the difference?
Wait, so if you use it as e to the power of t over 2, you still have the same?
Yes, totally. So if you just wrote e to the t over 2, plus c, also correct.
So if that was like 1/2 e to the 5t, then it would have been 1/2 e to the 5t over 5.
Yes. Okay, so in which case, all right, let's do that one. What do you say?
1/2 e to the 5t.
So maybe it was it's probably going to be written like this. Okay, so we're integrating that. So we know that means it's 1/2 e to the 1/2 e to the 5t. So our half stays there. And then our e to the 5t becomes e to the 5t over 5. So far, so good? Oh, shush now. That just says plus c. But we've got 1/2 and then e to the 5t over 5. So what's happening to these things? They're being multiplied. And how do we multiply fractions? No. Just top, bottom. So this becomes what?
E to the 5t over 10.
That's it. Perfect. These ones here, this middle one is very similar to one we've had a go at. This first one, we will learn something in a second about when you've got something to the square, but if it's to the square, you would FOIL it first. Okay? So you would expand this out and then integrate term by term. And then this you may have to struggle with. I'm going to remind you something about laws of logs. So I'm going to give you a bit of a moment to have a go at this, and then we'll put the answers up just to save time. Okay? All right. So there's the A and the B. So we FOILed, expanded it, simplified, and then integrated term by term. Second one, we split them, simplified, and then integrated term by term. Now, C. This is where we have to try and remember. You've got integral of ln e to the 2t minus 1 dt. Okay, I haven't put brackets, you don't need the brackets. Now, does anyone remember what's the rule when we've got a power and logs involved? We can rewrite this in a different way. You can totally bring it to the front camera. So this could be written as 2t minus 1. I would put it in a bracket now because I'm multiplying it, ln e. Okay? And this again is where you need to try and delve deep into the memories about logs. What does ln e? Natural log. Natural log is the ln, yes, but what does ln e? Pardon? What's this equal to? 0. What did you say, Scarlett? 1. So we know why this is equal to 1. Because this is log base e of e. And if you have the same base to the value, it's always equal to 1. So actually this is now off scheme. So we're just integrating 2t minus 1. And that's a nice easy integration. That's going to be 2t squared over 2 minus t. Obviously my 2's cancel out, so I've got t squared minus 1 plus c.